Good day, grade 8 students. It's me again, Ma'am Jen Ponteras, and welcome to Valenzuela Live Mathematics 8. With me is Mr. LDS Francisco as the lesson designer for this topic, and we have construct perpendicular bisector and angle bisector. In the next slide, we have a few reminders. Number 1, prepare your notebook. Number 2, listen attentively all throughout the discussion. Number 3, jot down all the important details. And lastly, if you have questions, type it in the comment section. At the end of this session, you must apply triangle congruence in constructing perpendicular bisector and angle bisector. Let us have our first activity. The scenario is, Myra wants to open a pasalubong center and thinks where she can open the business. She has a supplier from Barangay Lingunan, Barangay Malinta, and Barangay Parada, as you can see in our map. Where is the possible place to open her business, which is equidistant from her 3 suppliers? Let us think about this. I'll give you 10 seconds to think where is the exact location, or where is the possible location. The possible location is a certain place in Barangay Maysan. The point where the 3 medians of our triangle intersect is the centroid. As the median contains the centroid of our triangle, it seems that we formed 2 congruent triangles at a time. Can you imagine it? We can say that the certain place in Barangay Maysan is the right location for Myra to open her business nearby her suppliers. As you can see, we have perpendicular bisectors and angle bisectors in our figure. Do you still remember how we construct perpendicular bisectors and angle bisectors? Let us have our materials. You will need, in the next slide, you will need compass, ruler, pencil or pen, protractor for our performance task, and paper. So first, let us construct perpendicular bisectors. Our given segment XY, we're going to construct segment PQ, wherein segment PQ is the perpendicular bisector of segment XY, and Z is the midpoint of XY. The first step is you draw segment XY, then place the compass point on one end of the line at X and adjust the compass to just over half of XY. Then, draw an arc on each side of XY, as you can see in our figure. Then the second one, with Y as center, place the point of the compass at Y and adjust over half of XY. Then, draw an arc on each side of XY, as you can see on our figures. Okay, I'll give you time to observe the figures so you can figure out how are we going to construct perpendicular bisectors. Okay, let us have the third step. Draw a straight line between the intersection of the pairs of arcs. Name the line PQ, and Z will be the midpoint of our segment XY, just like in the figure. And lastly, segment PQ is now perpendicular, or is now the perpendicular bisector of XY at point Z. Okay, now let us take note these definitions that we're going to use in our proving. We will encounter radii, the plural of radius, or radius, a line segment from its center to the circumference of a circle. So its plural form is radii. We have here the definition all radii of a circle are congruent. And our postulate that we're going to use in our proving is radii of congruent circles are congruent. Okay. Now, from our construction, we have a conclusion. Segment XY is perpendicular to PQ and Z is the midpoint of XY. So we have our first statement, or in our proof, we have the first statement. Draw segment XP, segment YP, segment XQ, and segment YQ. The reason is construction. The second one, segment XP is congruent to segment YP, and segment XQ is congruent to segment YQ. The reason, radii of congruent circles are congruent. Then the next one, PQ is congruent to PQ. The reason is reflexive property of congruence. Then, the next one, triangle XPQ is congruent to triangle YPQ. The reason is SSS congruence postulate. Then the next one, angle XPZ is congruent to congruent to angle YPZ. The reason is CPC-TC. Then the last one, segment XP is congruent to segment YP. The reason is radii of congruent circles are congruent. Okay, so the continuation of our proof is in the next slide. The next statement is PZ is congruent to PZ. The reason is reflexive property of congruence. The next one, triangle XPZ is congruent to triangle XPZ, or triangle XPZ is congruent to triangle YPC. The reason is SAS congruence postulate. Then the next one, XZ is congruent to YZ, and angle XZP is congruent to angle YZP. The reason is CPC-TC. Then the next one, Z is the midpoint of XY. The reason is definition of midpoint. Then the next one, the measure of angle XZP is equal to the measure of angle YZP is equal to 90 degrees. The reason is congruent supplementary angles theorem because of 90 degrees. Then the last one, we can say that segment XY is perpendicular to segment PQ. Definition of perpendicular lines. Now, let us construct angle bisectors. So we have here the given angle C, and we're going to construct side CM, the bisector of angle C. So the first step is draw angle C. Given a circle with C as center and any convenient length of the radius, place the point of the compass at point C and draw an arc that intersect both sides of angle C. Label the intersection E and Q, as you can see in our figure. So we construct angle C, then later on we have the arc containing points E and Q. Okay. Then the second step, with E as the center, place the point of the compass at E and draw an arc in the interior of angle ECQ. So we have here the figure how we do the second step. So let's have the third step. Using the same radius and with Q as the center, place the point of the compass at Q and draw an arc that intersects the arc that drawn in step 2. Label the intersection point M. So you're going to do the same procedure on step 2 and label point M wherein the two arcs intersect. Okay, the last one, draw ray CM using the straight edge or ruler from point C and passing through the point M. So that would be the that would be the angle bisector, just like in our figure. Now, in our conclusion, ray CM bisects angle ECQ and angle ECM is congruent to angle GCM. So we have here our proof. In our first statement, draw angle C. The reason is construction. The second statement is draw arc RS. The reason is construction. Then the next one, CE is congruent to CQ. The reason is all radii of a circle are congruent. Then the next one, EM is congruent to QM. The reason is radii of congruent circles are congruent. Then the next one, CM is congruent to CM. The reason is reflexive property of congruence. Then the next one, triangle ECM is congruent to triangle QCM. The reason is SSS congruence postulate. Then the next one, angle ECM is congruent to angle GCM. The reason is CPCTC. So, we can say that CM is bisector of angle ECQ. The reason is definition of angle bisector. Now, let us keep in mind that perpendicular bisector of a segment is either a line, a ray, or a segment that is perpendicular to a given segment at its midpoint. Hence, dividing it into two congruent parts. And the angle bisector is a ray that divides the angle into two congruent angles. Now, before we end our discussion, we have the performance task to be discussed with your teacher. The instruction is, construct a perpendicular bisector and angle bisector in an isosceles triangle. Label the triangle and points in a triangle if any. Now, here's the task that you're going to be discussed with your teacher. After you draw all the perpendicular lines, did all perpendicular lines form a right angle? Why or why not? Among the perpendicular lines, is there a perpendicular bisector? Why or why you say so? After you draw all the angle bisectors, which of the angles are equal? Is there an instances in your drawing that angles are not congruent even you bisect them? So we are going to leave this to you and to your subject teacher. For question and answer, please type it in the comment section or discuss it with your subject teacher. For your assignment, kindly answer the modules 8 and 9, what's more. Again, I am Ma'am Jen Ponteras, and thank you for tuning in. Goodbye grade 8. Ingat tayong lahat.